The Antikythera Mechanism, discovered in 1901 in a shipwreck near the Greek island of Antikythera. It's considered the first analog computer. This ancient Greek device, dated around 100 BC, was capable of predicting eclipses, tracking the position of celestial bodies, and performing advanced astronomical calculations. What makes it extraordinary is its complexity, which would not be replicated for over 1,000 years. Sponge divers. They found the shipwreck at a depth of approximately 45 meters or 148 feet. Among the artifacts recovered were bronze statues, amphorae, and coins, as well as a corroded lump of metal. Initially overlooked, the artifact was later identified as a sophisticated device. Decades later, X-rays and advanced imaging revealed the intricate arrangement of bronze gears, dials, and inscriptions, confirming its purpose as an astronomical tool. The mechanism was made of bronze and housed in a wooden box roughly 33 centimeters by 18 centimeters by 9 centimeters. That's 13 inches by 7 by 3.5 inches. And while the wood deteriorated over time, the metallic components remained, albeit heavily corroded. The Antikythera Mechanism was not a single-use device, but it was a multifunctional tool that had advanced capabilities. Tracking the solar and lunar cycles, the mechanism incorporated the Metonic cycle, a 19-year period aligning lunar months with solar years. This allowed it to accurately display the moon's phases. It also used Ecliptic cycle, a refinement of the Metonic cycle over a span of 76 years. Using a gear system based on the Saros cycle, a period of 223 lunar months, the mechanism could predict solar and lunar eclipses with impeccable accuracy. It even indicated whether an eclipse would be visible from a specific region. Evidence suggests that the mechanism modeled the motions of Mercury, Venus, Mars, Jupiter, and Saturn, all the planets that were visible to the naked eye. The front panel displayed a rotating zodiac dial and star map, enabling users to see the position of celestial objects at a given time. It bridged the gap between solar and lunar years using very precise gear ratios, ensuring accurate calendrical predictions. And one dial marked the 4-year intervals of the ancient Olympic Games, highlighting cultural significance as well. The device contained at least 37 interlocking bronze gears, of which 30 survive in fragmented form. The largest gear, about 13 centimeters or 5 inches in diameter, had 223 teeth, matching the Saros cycle. The gears were precision cut, suggesting the use of advanced tools and possibly even a lathe. One of the most impressive features was its use of differential gearing, a mechanism allowing 2 rotational inputs to produce a single output. This specific technique would not reappear in European technology until the 16th century, and mechanical clocks of similar complexity would not emerge until the 14th century. So we have to ask ourselves, who created this? While the exact creator is unknown, the device reflects the Hellenistic tradition of scientific innovation. Some scholars link its design to Hipparchus of Nicaea, a Greek astronomer active around 190 to 120 BC. Others suggest it originated on the island of Rhodes, a major hub of ancient science and engineering. The ship carrying the Antikythera Mechanism likely sank around 60 BC. The vessel may have been transporting treasures from Rhodes to Rome for a wealthy patron. Alongside the mechanism, the wreck yielded luxury items such as bronze sculptures, glassware, and coins, and these findings help date the artifact and contextualize its historical setting. Over the years, researchers studied the mechanism using advanced tools like X-ray tomography and 3D modeling. These methods uncovered over 3,000 characters of Greek inscriptions, which included instructions and explanations of how to use it. In 2021, a team at University College London created a functional replica using modern materials, providing new insights into its capabilities. And despite extensive research, there are many questions that remain. What was the Antikythera mechanism unique for? Or what part of a tradition or similar devices are also now lost to history? Who exactly designed and built it? And was it intended for widespread use or only for the elite? And how did such an advanced technology fall out of use for over a millennium? The Antikythera mechanism changes how we understand ancient technology. It demonstrates that Greek engineers and astronomers of the 2nd century BC were capable of designing devices with precision unmatched until later in history. Its discovery challenges the notion of technological progress as linear, suggesting that ancient civilizations achieved remarkable feats that were later forgotten. Today, the mechanism is housed in the National Archaeological Museum in Athens, Greece, where it continues to inspire scientists, historians, and engineers. These are Interesting Things with JC.